Python Destructor basing on try/finally plus yield. I've been testing a dirty hack inspired by this URL. The main idea is to bring try/finally idea onto class level and get reliable and simple class destructor. But it always gives me and never releasing resources. I'm basing my hope on. As of Python version 2.5, the yield statement is now allowed in the try clause of a try/finally construct. If the generator is not resumed before it is finalized, by reaching a 0 reference count or by being garbage collected, the generator iterator's close method will be called, allowing any pending finally clauses to execute. Source link. But it seems when the class member is being garbage collected together with the class, their ref counts don't decrease, so as a result generator's close and thus finally is never called. As for the second part of the quote, or by being garbage collected, I just don't know why it's not true. Any chance to make this utopia work? Smile? BTW, this works on module level. Output will be as I expect. Note, in my task I'm not able to use with manager, because I'm releasing the resource inside end_callback of the thread, it will be out of any with. So I wanted to get a reliable destructor for cases when callback won't be called for some reason.
The problem you are having is caused by a reference cycle and an implicit _del_ defined on your generator. It's so implicit, Python doesn't actually show _del_ when you introspect, because only the C-level TP_del exists. No Python visible _del_ is created.
Basically, when a generator has a yield inside a try block, or equivalently, a with block,
it has an implicit _del_ like implementation. On Python 3.3 and earlier, if a reference cycle contains an object whose class implements _del_, technically, has TP_del in Python, unless the cycle is manually broken, the cyclic garbage collector cannot clean it up, and just sticks it in gc.garbage, import gc to gain access, because it doesn't know which objects, if any, must be collected first to clean up nicely. Because your class is _acquire_resources_self, contains a reference to the instance's self, you form a reference cycle. Self.res_mgr_, generator object, generator frame, referencing locals which includes, self. Because of this reference cycle, and the fact that the generator has a try/finally in it, creating TP_del equivalent to _del_, the cycle is uncollectible, and your finally block never gets executed unless you manually advance self.res_mgr_, which defeats the whole purpose. Your experiment happens to display this problem automatically because the reference cycle is implicit/automatic, but any accidental reference cycle where an object in the cycle has a class with _del_ will trigger the same problem, so even if you just did
if the resources involved could conceivably lead to a reference cycle with an instance of foo, you'd have the same problem.
The solution here is one or both of. Make your class a context manager so users provide the information necessary for deterministic finalization, by using with blocks, as well as providing an explicit cleanup method, for example close, for when with blocks aren't feasible, part of another object state that is cleaned up through its own resource management. This is also the only way to provide deterministic cleanup on most non-Python interpreters where reference counting semantics have never been used, so all finalizers are called non-deterministically, if at all. Move to Python 3.4 or higher, where PEP 442 resolves the issue with uncollectible cyclic garbage. It's technically still possible to produce such cycles on Python, but only via third-party extensions that continue to use TP_del instead of updating to use the TP_finalize slot that allows cyclic garbage to be cleaned properly. It's still non-deterministic cleanup. If a reference cycle exists, you're waiting on the cyclic GC to run, sometime, but it's possible. where pre 3.4, cyclic garbage of this sort could not be cleaned up at all.
If you want to support the channel, please consider subscribing.